So let's talk about troubleshooting Spark jobs. What happens when something goes wrong or you think something might just be stuck? Well, to be honest, it's a little bit of a dark art. You don't always have a whole lot of understanding about how Spark is actually distributing your application or why things are failing exactly. Oftentimes the messages are rather cryptic. But one tool in our arsenal is the Spark UI. The Spark master node will actually fire up a web server for you that provides a little glimpse into what's actually going on inside your script at all times, so you can see what stage it's on and how it's distributing things all in real time, which can be kind of useful. Now, the downside is that if you're using something like Amazon's Elastic MapReduce, actually connecting to that UI is extremely difficult. It's not impossible. They actually give you instructions in the EMR dashboard on how to connect to your master, but it involves creating an SSH tunnel to your master node from your desktop and also configuring a proxy server from within your web browser. So it's a real big pain in the butt. And in practice, I find it's just as easy to just look at the log messages as they're scrolling by while my job is running. Often that will give you some insight into what's going on anyway. But if you're running locally and testing things out, or you're running on a cluster that you do have direct access to on the network, the Spark UI can be pretty useful. So let's take a look at how it actually works in an example running on our desktop. So let's take a quick tour of the Spark UI. What I'm going to do is run that movie similarities script on my desktop here that processes the 100K ratings data set locally, and that'll run for about a minute, which is just enough time for me to spark up the UI and show it to you. So again, we're going to connect to port 4040 on the host that you're running on from a web browser. So in this case, I'm running on my local host. The IP address of your own machine is always 127.0.0.1. So by directing my web browser to http://127.0.0.1:4040, that will connect me to the Spark UI once Spark is actually running. So with that, let's kick off our movie similarities job. And we'll refresh 127.0.0.1:4040. Now, before that job finishes, I'm going to go ahead and open up all these different tabs here so we can take a look at them, because it only runs for about a minute. And you can see that we have on the jobs page here details of everything that we're running here. You can actually drill into individual jobs and get more information about what they're doing, how much time they're taking, and how much garbage collection time is taking. So you can use this information for tuning your job and figuring out if you need to partition things better. DAG visualization, that's pretty cool, huh? You can actually see the DAG here and how it's been split up for this particular stage in a graphical manner. That's pretty hot. That's kind of a recent thing. You can actually go into individual stages as well, so you can see how Spark actually broke up the job into individual stages here, and you can visualize those stages independently too. So this is great for optimizing your script. Do you have more stages than you think you need? Remember, stages represent points at which Spark needs to shuffle data. So the more stages you have, the more data is being shuffled around and the least efficient your job is running. So there could be opportunities to explicitly partition things to avoid shuffling and reduce the number of stages. And by studying what's going on here, that can be a useful way of figuring it out. The environment tab gives you some just general troubleshooting information about the environment itself. So, if you have any questions about, do I have the right Java version installed? Do I have the right Scala version installed on my cluster? This will give you the answer. And this tells you that I'm running on Scala version 2.10, for example, Java 1.8. If you're running into weird compatibility issues where things worked fine on your desktop, but they don't work at all on your cluster, well, that might be why, and this will tell you why. Information about the Spark job itself. Also useful things, the path for Java. So again, if you're having trouble with dependencies and trying to figure out why a certain library isn't loading, that might tell you why. And more general information about the configuration of Java on your machine. Also, we have the executors tab here. That's actually telling you how many executors are actually running. And since I'm running on my local desktop, it's not too surprising that I just have one executor, but actually it's a little bit surprising because I thought I told it to use every core. So for whatever reason, Spark decided that it didn't actually need more than one executor to complete this job. Now, if you were running on a cluster and you were looking at this and you saw only one executor, well, that would be a sign of trouble, right? That would probably mean that things aren't configured right on your cluster. Maybe you left something in the configuration on in the script itself to run locally or restrict the number of executors, and that would need to be taken out, for example. So that's the Spark UI in a nutshell, and the job's already completed, so let's kick it off again. As soon as the job's done, it shuts down that web server. But we're back up in action now here. So just click around, kind of play around, and I don't know, that DAG visualization I think is pretty hot. So anyway, if you want more insight into what's going on, the Spark UI is there for you, and it can tell you a lot more about how your job is actually being executed and constructed into a DAG. So the Spark UI is just one piece of the troubleshooting pie. As we said, logs can also be really helpful, and oftentimes you can just look at the output that's scrolling by as your job runs on the master node to see what's going on. If something's failing, you'll probably say, something timed out or a heartbeat failed or something like that, and that's a good sign that your cluster just isn't big enough, or maybe you didn't partition your job well enough. Go back to those partitioning slides we went through and see if there are opportunities to explicitly partition some of the operations you're doing, like joins or group bys, to make your job run more efficiently. If not, you might just need to throw more hardware at the problem. Sometimes a job is just too complicated for a small cluster to handle, and if you're seeing things time out consistently or lose heartbeats and keep losing and trying to respin up executors, that's a good sign that you just have a capacity problem and you need to throw more hardware at it. You need a bigger cluster, okay? Now, how do you actually look at the logs if you want to, if you're capturing them? Well, if you're running on top of yarn, you can just use the yarn logs command with the application ID that you were running with, and that will retrieve them all for you. Thing is, on a cluster, those logs are all going to be distributed amongst all the different executor nodes, so reassembling them requires a little bit of work. Now on EMR, you also have the option of dumping those logs to an S3 bucket, so you can get them all together there as well. So when you're spinning up your cluster, there's an option that's actually checked off by default to actually save the logs to S3, and it gives you a default path that it saves them to. So you can just copy and paste that path somewhere and go check for them later. So again, the main thing you want to watch for, the thing that most commonly comes up, is that you just don't have enough capacity. And again, if you see a lot of timeouts, a lot of heartbeat failures, you might need more capacity, you might need more memory per executor. That's worth a shot too. You might just be running out of memory. And or you might just need to partition your job better by partitioning. So try all three things. In order of cost, right? Partitioning is going to be the easiest thing to do. Allocating more memory per executor is probably the second easiest thing to do, and actually adding more capacity should probably be your last resort, right? All right, one other thing besides troubleshooting I want to cover is managing dependencies on a cluster. So always remember that your executors aren't necessarily running on the same box as your driver script. So if your executor nodes, the things that are actually running your mapping functions and whatnot, require data that actually physically resides on the disk of your master node or your desktop, that's not going to work. You're going to find that will fail pretty darn quickly. So remember to use the techniques that we covered earlier in the course, like using broadcast variables if you need to share data across RDD partitions. Or make sure that any dependencies you have are loaded ahead of time on each node. If, for example, you might have some dependency that's not preloaded, and one thing you can do, the standard thing to do, is to use SBT to actually bundle all of those dependent packages into your jar. You can also use the --jars option on Spark Submit to make sure that any jar files that contain code libraries that your script depends on is automatically distributed along with your script to the entire cluster. But really, you should just avoid using obscure packages in the first place. If you are using some weird Scala or Java package just because you're too lazy to write 2 lines of code, well, the hassle it takes of actually distributing that dependency to your cluster is very quickly going to negate the benefit of using it. So whenever possible, try to just use the core language features of Scala whenever you can, and the core of Spark. Obviously, sometimes it's unavoidable if you need to connect to a specialized data store or system, but try to keep those dependencies to a minimum as a good best practice. And that's my tips for running on a cluster. So good luck with that. Next, we'll talk about some more powerful Spark technologies built on top of Spark Core and how those work.